Do you guys have any other questions on this page right here? No? All right. Sigma notation is basically what we're going to do is, do you guys remember sigma notation?
Yeah, we did in summation.
Kind of. Yeah.
Summation notation? Yeah.
Stat.
Yeah. So you actually will be using it a lot in this class. The last unit is all using sigma notation. So let's see. Just as a reminder, sigma notation is like if I have, guys, sum of 1, 2, 5, like of x. That would be, let's do x squared. So this will be equal to 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, and then you stop at 5, right? Does everybody remember that?
Yeah.
Yeah?
It's more
Okay.
like your nail color.
Thanks. I just did it. Yes, last night. So basically what we're gonna do is we're gonna write these rectangles that we did on the other page in summation notation. So we're gonna write it as if we want an infinite amount of rectangles. So wait, let's graph this line. Y equals 2x. That's 0, 2, 4, straight line. Like that. Okay. All right. If the interval 1 to 2 is portioned into 4 equal subintervals, what's the width of each subinterval? So if I cut it into 4 subintervals, what's the width of each subinterval? What's the width from 1 to this point? What would be the width? 0.25, right? Or 1/4, right?
It's a male hydroflux.
Literally.
Everybody good? Okay. Let's say I divide it into n equal portions. How would you find delta x? We did this on the previous page.
So it's like the last one is the first one.
Yep.
The width of each.
Over how many partitions you want, right? The b minus the a over how many partitions you want. We want n partitions. So it would be 1/5. Or sorry, not 1/5, guys. 1 over n. So if I wanted 5 equal partitions, each width would be 1/5. If I wanted 7 equal partitions, each width would be 1/7, right? Okay, we're gonna call one of the subintervals the kth subinterval. Find an expression for the right-hand endpoint of the kth subinterval. So here I am at 1. We're gonna do a right-hand Riemann sum. So we're gonna go right over down, and then up to this point, right over down, up, right over down, and then at 2, up, over, down. Okay. So the width from, let's do a closer up view. 1. This distance right here is, how much is that? What did we say? Well, for this one will be 0.25, but this one will be 1 over n. Right? And then to the next subinterval, it would be 1 over n as well. Yes? And then the next one would be 1 over n. Right? And we would keep doing that until we got to 2. right? So this location right here, the second location would be 1 plus 1 over n. Yes? Are you with me? This location would be what? 1 plus 2 over n. This one would be 1 plus 3 over n, right? So if I have the kth subinterval, my expression would be 1 plus k over n. Right? If I wanted the 7th subinterval, it would be 1 plus 7 over n. That would get me to where I am at 7. Okay? All right. Now, after we find the width of each subinterval to get us to those locations, I need to know how high I go. So how do I figure out this point and this point and this point? They all lie on what graph? The 2x graph, right? Yeah? All these points come from 2x. So what I do is I plug in this subinterval, my x location, into my f of x equation, and I can get what my height is for each of those. So it would be, the function is 2x, so I would do 2 and plug in 1 plus k over n. So there's now my heights for each one, right? Okay, how do you find the area of a rectangle? You multiply the base times the height, right? The base is 1 over n. I'm going to put that second, 1 over n. And then times the height. The height of your rectangles are all from this one. 2 times 1 plus k over n. I don't know why I did 2 parentheses. So there's our expression for the area of a rectangle. One rectangle. Okay? And then what we want is we want the number of rectangles to go to infinity. So we write sum starting at the first rectangle, going up to the nth rectangle of, now we add up all of our areas of our triangles. This is the area of all of our triangles. And then we want the number of rectangles to go to infinity. So what this does is we go limit as n goes to infinity in front. So our number of rectangles approach infinity. And that's the area under the curve, the exact area under the curve. Okay? What this represents is an integral, a definite integral. So this is equal to, and this is integral notation, this is equal to the integral from 1 to 2 of our function 2x. So this is our function, but since we're going to infinity, instead of writing like this delta x like this, we write a dx. So this is our height times our base. But since our base is getting infinitely small, we write dx instead of the 1 over n. Is this weird?
A little weird.
It's crazy?
I like it. Can we go back to the
No. Okay, let's keep going. So the more you do, the more you'll get better at it. So let's start with 3x. Okay? So 3x, here's what we do. Let's do a graph of 3x. Okay. So here's our graph. Let's figure out the width of our interval. So our delta x, we want to figure out what is our delta x equals. we go width of our interval 2 minus 0
Stop.
over the number of rectangles I want. Okay? All right. The next is we need to find out, we need to make a right hand endpoint for each one. So what we do for our right hand endpoint is we start, see how it's 0 is where we start? Our right hand endpoint would be 0 plus, and then an interval. Our interval is 2 over n. So it's 2 over n k. Okay, so that is my x locations, right? Okay, then I want to find my height of my rectangles. So I take this and I plug it into my function. So it would be 3 times 0 plus 2 over nk. Okay, and then to find area, we multiply my height. So this is my height. Times my base. That's how you find area, is you multiply base times height. Okay, then you want to add them all up, so we do sum. N equals 1, 2, k equals 1. My bad. Let's do k equals 1, starting at 1 to n, and we want the number of rectangles to go to infinity. I know, well, stop talking and maybe you'll understand. Okay, this equals the area. So area, this is equal to this integral. Integral from 0 to 2 of 3x dx. Yeah.
So is the reason that this sum is k equals 1 when the previous one was n equals 1?
No, it should be, I should have done this one as k. Start so that you plug 1 in for k, and then you plug 2 in for k. My bad. Okay, let's try again. Another one. Okay, 2x squared. From 0 to 2, so I only need to know the right-hand side. So this is a parabola pointing up like this, right? Okay. So we want to find the area from 0 to 2. Let's say 2 is here. This one was from 0 to 2. Let's say 2 is here. So we found that area. This one we're finding this area. Okay, let's take it step by step again. First, let's find the width of my rectangles. Okay, so how do I find that? Delta x. Okay, how do I do that?
2 minus 0.
Over
n
n. Perfect.
equals 2.
Okay, equals 2 over n. It's the same thing. Sid, are you good with that?
Yeah.
Okay, now, next step. We start at 0. Here we are at 0, right? And I want to do a right-hand Riemann sum, so I'm trying to get to this point, the first, like, sub-interval. So I can go up and then draw a rectangle over, right? This point would be 0 plus 1 increment, 2 over n, right? Yes? And then the next increment would be 0 plus 2 over n times 2. And the next one would be 2 over n times 3, right?
Yeah.
So our increments become 0 plus 2 over n k, with k being whichever interval I want. Okay. If I want the first one, k would be 1. If I want the second one, k would be 2. Third one, k would be 3. Okay? All right. After I do that, once I know where my subintervals are, what's the next step?
Summation.
Well, let's find the height of our rectangles first.
Oh, true.
Okay. How do we find the height of our rectangles? Well, if I wanted to know where I was at 1, what would I do? I will plug 1 into this, right?
Yeah.
To find the height, right? So this is the same thing for this. I would plug in 0 plus 2 over nk into my f of x equation. Okay, so that's the height of my rectangles. Are you with me there?
Yeah.
Okay, then to find area, I gotta multiply by my base. We already figured out our base. Our base was 2 over n, right? And then now, Alan, we can add them all up together. So we go add
Summation.
k equals 1 summation to n, and we want the number of rectangles to go to infinity. And there's our summation notation of a Riemann sum. Okay.
Wait, how come we didn't put that one in brackets?
Oh, yeah.
Does it matter?
It doesn't matter.
Oh,
Yeah.
Why is that what you're confused about?
Oh, because what I want to do is if I'm trying to find exact area, what I want to do is I want to make like the tiniest little rectangles.
Yeah, but like, wouldn't that eventually come to like a half?
What?
No.
No,
The
it
smaller
goes on
the
to
rectangle, the more accurate your area,
Oh.
right?
So you
So
can
if
keep
my
it very
number
small.
of rectangles gets smaller and smaller and approaches infinity, then I'll get the most exact area.
So you just keep on drawing smaller lots.
Yeah.
Basically, that's what this.
Smaller, yeah, skinnier and skinnier. Sarah?
Why does k equal 1?
Oh, because you always start at the first subinterval away from, like for a right Riemann sum, you always start one subinterval away from your initial point.
So it doesn't n mean that you don't know the subinterval?
No, n means the number of subintervals.
So how do you know that k equals 1 if you don't know the number of subintervals?
No, n will go to, like I can plug in any number I want to, but I gotta start, k is the increment counter.
Oh, okay.
So it's like n is the number of subintervals, but k is like which rectangle you're on at each moment. For example, this one, it's like this increment counter means like start with the first rectangle, then do the second rectangle, then the third rectangle, then the fourth rectangle. Does that make sense?
Yeah.
Okay.
Why is the base 2 over n?
This one?
Yeah.
Oh, because you're going from 0 to 2, and if you want n subintervals, then the base, like, if I want 5 subintervals, then it would be 0, and then 2/5 through 4/5. Yeah. Okay. All right. Let's keep. Anyways, this is equal to the integral of 0 to 2 of 2x squared dx. This is f of x. This is the height. This is your base still. Height, base. That's why you need the dx there. Okay, why don't you try C and tell me if you get the same answer that I do.
So you're gonna ask for all three versions, like for us to sketch something, and then find the Riemann sum.
No, I'm just going to ask for this one.
Okay.
But you got to get there.
Yeah.
I should have switched it up.
I like it.
What a big coinky.
What do you think?
Yeah, it's a big coinky.
This actually makes sense.
What is this?
No, I'm just following.
I feel like he always says like, oh, this actually makes sense. And then it's like a too long
what?
standard.
Be quiet.
Yo, chill. Yo, like,
Just
pose
kidding.
it.
Come on. I didn't find it funny.
You don't have to draw like upside down. It's negative.
Yeah.
Yeah.
Upside down.
So did you start at zero still?
No. What? Negative
For
1 to
parabola.
1.
Oh yeah. Oh,
Is
I
it
made my
seven?
integral. Yeah. Facts.
Check your answer with mine once you were done.
Oh my. Wait, is it the substitute for like, you know how we have 0 plus 2n over k? Is that just the first value of the left?
This one?
Yeah. Like negative 1 plus 2nk. Like, is that negative 1 just like your first value of your interval?
Yeah, -1 is your first location of your interval. Because you're trying to go to -1 and then you want, for a right Riemann sum, you want to go one interval to the right of it. Yeah.
Makes sense.
I mean, like.
Okay, do you get it?
No, wait. Go back.
I actually got it. What the heck?
I get it. I just.
It takes a minute, but the more you do, the...
This boy did it. I don't understand why
I'm so proud of you.
I know.
Yeah.
So what does the dx mean, and will it always be used, or is there something we use?
The dx is the base. It's like delta x. This is delta x times your f of x, right? Your function. So it's the same thing when you do the integral. The f of x is the function. The dx is really your interval that you're multiplying by. But the problem when you go to infinity is the size of your delta x gets smaller and smaller and smaller. So you don't write like nothing. This doesn't affect the integral in any way. So that's what the dx means. Okay. Yeah.
Will the n
It's representing
will
area.
n always approach infinity, and will k always be 1? Like just for like simple stuff like this.
If I said write a Riemann sum with 5 rectangles, then k will always be 1, but n would be 5.
Okay.
And if I wanted 10 rectangles, n would be 10.
But if you're asking us like in terms of n.
In terms of n, it will
Yeah,
always be
always-
infinity.
Okay.
Yeah. Okay. Ready? Yeah. Okay, use your calculator to evaluate the definite integral. So this is how you use your calculator to do integrals. And integrals, you know how derivatives, you can only take a derivative at a singular point. Integrals you can only do if you have defined boundaries on it. So what was derivative? What button do you press for derivative? Math 8, right? Math 8 was derivative. Well, Math 9 is integral. Okay, so go Math. And then choose number 9. And you should see an integral thing here where you fill in the 1, the 2, the function, and then you got to say with respect to x, dx. And tell me what answer you get.
2.5.
2.5. 5 over 2.
See, why could you just do everything with the calculator? It's so
Okay.
easy.
Wait, are you with me?
Math 9. KK. I said that in class.
Okay.
In my history class. My teacher said I said KK.
So, they already did the Riemann sum for you.
Everyone does.
I don't know if you can do limits on your calculator. Is there a limit thing on your calculator?
I don't think so. Okay, is Mira the only guy?
Okay, let's skip B, C, and D then. All right. So I'm going to ask you to do A, B, and C and write the limit expression and then use your calculator to find the value. But before we do that, I also want you to do the bottom. So we're going to do one example down here and then of going backwards and finding the function so that we can figure out how to solve these. Okay, so to solve these, the first part of our integral, we need to find our bounds, okay? Now the bound start will come from our first location of what we plug in. So that's this plus 2. Because remember from before when we were doing the last problem, like it was like your initial value plus your width of your interval, right? So 2 is going to be our starting location. How do we figure out where we end?
Infinity. So
No.
the base.
The base, yeah, so it would be like.
So where?
So it would be like
So,
5.
okay, so from the 3, right? This is our width of our
I was getting there.
interval, right? So if that's the width of our interval and I'm starting at 2, then my width is 3, then I'm ending at 5, right? Okay. Now we just figure out what's the function that I want to take. What's my function? 3x minus 8. And then this thing right here is a dx or a delta x, right?
Are we just working backwards now?
Yeah, we're working backwards. Okay? It shouldn't be too bad. So why don't you try A, B, and C, and this B and C, and once you get it, check your answers. I'm going to do it too. And then once you check your answers, then we're done for
Call
today.
it quits. Bro, that's really cool.
But try it before you look at my answers.
Wait, what?
True.
What were you saying?
Don't worry, it's not about you.
I literally heard my name.
Oh, she got me there.
You're so annoying. That's not true.
I think that's facts.
It's not. Yeah, I know. You're in accordance with part 2.
Guys, just finish this before you...
Sorry.
We're multitasking.
No, you're not.
How do you get the values so quick? Are you plugging them into your
K
calculator?
is always 1.
Oh, true. This one.
What?
Are we plugging in the values?
Yeah, you just plug this integral in your calculator. I made all of these 2K also. Alan, it's probably not the best.
For the 2 times 1 plus 2k, would you have to add a 1 also?
Which one?
The first one? where you're
I did
plugging
one.
it in.
Oh, plus 1 on the
Yeah.
end. Thanks, Gwen.
Okay. Just checking.
Thank you. Good catch.
Yeah.
For multiple choice.
This week went by so fast.
This week was the
That's
longest
so
week
much
of my
fun.
life.
I was busy with the title, so it went by fast.
can't do 805 every day. I can't get up to that day. No, hold on.
You can just move it to 5, but that's not bad.
I'm sorry, I live a million miles away.
Okay. Try to finish them and then check yours with what's up here. And when you're done, then that's it for you guys.
You